Hi class, welcome to Tests and Measurements, PEP 289 with me, Elizabeth Harding. We are going to talk about a two-way ANOVA and go through your homework assignment task by task. So there are going to be 4 tasks per this assignment, and we are going to talk about task 1 in this first video. So task 1, let me pull over your homework assignment. Here it is, the Word document. We are looking at a data set of weekly step counts of 300 individuals, school-aged children, ages 5 to 11. So we have 150 males and 150 females, also divided by 3 different regions. So North America, Europe, and Asia. And what I've included here is a data dictionary. So this will help you look at the codes or interpret the codes on the data set. So for instance, within the gender or sex variable, 1 is male and 0 is female. And region 1 is North America, 2 is Europe, and 3 is Asia, etc. Your weekly pedometer steps are your only continuous variable. And whether or not the student does at least 8,500 steps, 0 is no and 1 is yes. And this will come in to play when we discuss task 4. Right, so your first assignment is to determine if there is a difference between boys and girls regarding their weekly step count. So you'll run the appropriate statistical test, and you can see here I've given you a little help table in Appendix A. So if we scroll down to Appendix A, you can see that this is from your statistical choice cheat sheet that I had given you in class one day. We have 1 nominal independent variable divided into 2 groups, males and females. Our dependent variable is 1 continuous variable, which is weekly step counts here. And so the statistical test that we're going to use is a t-test. We are going to use an independent samples t-test to look at the differences between the groups. Okay, so heading back up to what you are required to do for this first task is you'll run the appropriate statistical test, you'll report means and standard deviations, and then provide a graph of your findings. So let's go ahead and look at our data here. All right, so we have gender, region, and pedometer steps. So in order to look at the differences between men and women, or males and females, I am going to sort by gender. So you should be old hands at this particular step. I'm going to select the entire data set because I want to make sure that everything follows along with their gender column. And I'm going to go up to my sort function here, custom sort, and we want to sort by gender, or sex is the more appropriate name. All right, so now you can see that I have, since I have 150 participants, from cell C2 all the way to cell, let me see, and I've just made notes of this, right, to cell 151 represents, the females, so 0 is females. Okay, so if you have really large data sets, it's always handy to kind of make a note of the starting and stopping cell. So to find the mean of, let's start with the females since they're on the top row, equals average. And then I can either just select this first weekly pedometer step count, so cell C2, and then a colon to C151 is where the female data ends. Okay, and so for males, I know that the male data is contained from cell C152 to C301. So I don't have to scroll all the way down through my data set. The standard deviation, the same thing. We're looking at a sample, C152 to C301. C2 to C151. Okay, and if you've gotten really creative with your headings and you've added some rows above it, you just want to make sure you check your cells to make sure that all of your data is being included. Okay, so there are my means and standard deviations. So I've asked you to report those. And now we're going to find our p-value to see if there is significance. So rather than finding the t-score, right, which you certainly can do, and you can look at your t-table and find the t-critical that you have to exceed in order to find or to determine significance, we're just going to do a standard t-test, right, an independent samples t-test, which is going to return a p-value or a probability. All right, so equals t dot test, parenthesis, and then we're going to select array 1, which is let's do the female, all the female step counts. I'm just going to scroll. Yep, it takes a while. Come on. Okay, so right there. And then I'm going to select array 2. So I just did a comma, and then we're selecting all of the male data. And of course you can type from cell to cell, that's fine. It would certainly be a lot shorter than this. Take a lot less time. Okay, and then 2, and then for the type, it is 2, right? So if we go to our little help here, all right, thinking about it. That took a while. So just to recall, so array 1 is all of your female data. Array 2 is your male data. We want to do a two-tailed distribution, and the kind of t-test, we do not want to perform a pair test, right? So our participants are not serving as their own controls because we have males and females. So we are performing a two-sample homoscedastic test, which means that we're assuming that the variance is fairly similar between our two groups of males and females. Okay, so 2. So you should have on your formula, you will have, scrolling back up, right here, you can see it right here, right? Our arrays, 2 tails, independent samples. Go ahead and close the parentheses. Not necessary, but let's do it anyways. And it returns a p-value of 0.108. Okay, so that is not significant. All right, so provide a graph of your findings. I'm going to let you tackle that one on your own because all of you are very familiar with how to do a graph. One thing that I would like to add to this assignment is that I would like you to include error bars. So I'm just going to write that in there. Using your calculated standard deviations. Okay. All right, so that is task 1.